Have you heard about Phyllis hairs? It's this thin filament of lava. Therefore, when lava is falling over an edge and the wind is blowing, you can find this kind of formation. They cool down very quickly and look like hairs. And they're actually pretty hard to find after an eruption. And that's because they break very easily, so they turn into dust very quickly soon after the formation. So I have some ice. You want to see what's happening if I put it on top? Yeah? So I'm going to put the ice on top. The lava is going to cool down very quickly. And when lava is cooling down very quickly, there is no time for crystal to appear inside the lava. And you're just turning the lava into what it's most made of. And it's most made of silica, 47%. So you're just turning the lava into a volcanic glass. So what's happening here is some of the steam is going up, but some of it is being pushed and forced inside the lava and make it blow like a balloon. And that's what you can see here a little bit. It's just the steam trying to escape. But at the same time, lava on top is getting more solid, so it's kind of trapped there. Of course, if it's too thin, it might go through, and everything could collapse like a souffle. And you can see where I put the ice on top. It's turning black very quickly. Just turning into a volcanic glass. And behind, in the channel, you can see that the lava is not moving anymore. But inside, it's still very hot and liquid. And that's because lava is cooling down over the edge of the flow. And by doing so, it's actually insulating the lava fluid inside it. So in nature, in the open, lava is losing around 100 degrees Celsius every kilometer it's flowing. But when traveling under its own insulation, like it's doing the channel at the moment, it's just losing 1 degree. So it can stay hot for a very long time and travel very long distance underneath. And because of that, I can go under it and I can lift it. And that's because it's already on the edge, at least where I'm lifting it. But inside, it's still very hot and liquid. And if lava is flowing on a slope in nature, maybe the lava will be able to flow out of its own insulation. And if the lava is flowing out, you would just leave an empty tunnel behind. And that's the way to do lava tunnel or lava tube. And you can see inside still hot. Like, pretty viscous, but still very hot. And the same thing is happening in the front. Over here, solid on the surface, liquid inside. So let's see if I can show you. Oops, I broke the bubble at the same time. But you can see inside still very hot. And I can go in, lift it, and I can do the Phyllis hairs almost like the start. And that's because in this area, the lava hasn't lost a lot of temperature yet. And you can see that by the color. When I'm lifting it, it's still yellow, and then turn orange. The yellow is kind of the hottest color we have here. Of course, all the color are pretty hot, but yellow is kind of the hottest one in this condition. And also when I'm lifting it, and it's getting thinner, it's also losing the color pretty quickly. Of course, right now I just speak quite a lot actually, so it's not as fast. But where it's very thin, generally turn black very quickly. I can already see that compared to when I just did it like a minute ago, it's already getting more viscous now. Because it's